13.8 billion years ago, everything you know exploded into existence from a point smaller than the period at the end of this sentence. But here's what keeps physicists awake at night. What caused that explosion? We're about to journey through parallel dimensions, colliding universes, and quantum foam that bubbles with infinite possibilities. You'll discover how black holes might birth entire cosmos, why our universe could be one of infinite bubbles, and the shocking truth about what existed before time itself began. Make sure to like and subscribe because this journey will change how you see everything around you. Prepare yourselves. We begin. Picture absolute nothingness. Not darkness, not emptiness, but the complete absence of space, time, matter, and energy itself. This is the ultimate mystery that haunts every physicist on Earth. What existed in that final moment before our universe burst into being? We call it the Big Bang, but that name tricks us into thinking it was an explosion in space. The truth is far stranger. Space itself was born in that moment. Time started ticking for the first time. The very concept of before becomes meaningless when time doesn't exist yet. Think of it like trying to find the edge of a sphere by walking on its surface. You can walk forever, but you'll never reach an edge because the sphere has no beginning or end. Similarly, asking what happened before the Big Bang might be asking the wrong question entirely. Some scientists believe that before our universe, there was a quantum vacuum, not empty space, but a thing of potential energy where particles pop into existence and vanish in less than a trillionth of a second. This quantum foam bubbles with possibilities. Virtual particles dance in and out of reality so quickly that they barely exist at all. But here's where it gets mind-bending. In this pre-universe state, the normal rules of physics break down completely. Cause and effect become meaningless. Something can happen without anything causing it to happen. The universe might have literally created itself from nothing through pure quantum chance. Imagine flipping a coin that has no heads or tails until the moment it lands. That's what the pre-Big Bang state was like. Pure potential waiting to collapse into reality. But this wasn't just any coin flip. This was a cosmic lottery where the winning ticket created 13.8 billion years of stars, planets, galaxies, and eventually you sitting here wondering how it all began. The mathematics become so extreme that our best theories simply stop working. General relativity predicts that at the moment of the Big Bang, density and temperature became infinite. But infinity isn't a number. It's mathematics screaming that we've reached the edge of human understanding. We need a theory of quantum gravity to peer behind this cosmic curtain. But even our smartest scientists are still building those mathematical tools. What makes this even more fascinating is that multiple scientific teams are now detecting gravitational waves, ripples in space-time itself that might carry echoes from before the Big Bang. These cosmic whispers could be our first real clues about what triggered everything. We're essentially cosmic detectives trying to solve a case where the crime scene is the entire universe. But if the Big Bang wasn't caused by something that already existed, then what sparked this cosmic explosion? The answer might lie in the strangest place of all, the quantum world, where reality itself operates by different rules. Deep in the quantum realm, empty space isn't actually empty at all. What we call a vacuum is actually buzzing with invisible activity. Pairs of particles constantly pop into existence, dance together for an impossibly brief moment, then annihilate each other and disappear. This happens everywhere all the time, even in the space between your atoms right now. It's like having an invisible fireworks show going off in every cubic inch of reality. These quantum fluctuations usually balance out perfectly. A particle appears, its opposite appears, they cancel each other out, and the universe continues as if nothing happened. But what if something went wrong with this cosmic accounting system? What if just once the books didn't balance? Picture a perfectly calm lake where tiny waves constantly appear and disappear so quickly you never notice them. Now imagine if one of those waves, instead of disappearing, suddenly grew into a tsunami that flooded an entire continent. That's essentially what some physicists believe happened when our universe began. In the quantum world, there's something called the Heisenberg uncertainty principle. It says that for incredibly brief moments, energy can be borrowed from nowhere as long as it's paid back quickly enough. It's like the universe has a cosmic credit card with no spending limit, but the bill comes due almost instantly. Normally, these quantum loans get repaid so fast that reality never notices the debt. But here's the incredible possibility. What if one of these quantum fluctuations was so massive that it couldn't be paid back? Instead of disappearing, it had no choice but to inflate into an entire universe. Our cosmos might literally be the result of the ultimate cosmic bankruptcy, a quantum debt so large that reality had to expand infinitely just to contain it. The mathematics actually support this wild idea. In quantum field theory, the probability of a massive fluctuation creating a universe isn't zero. It's incredibly tiny, so small that you'd need more time than the age of our universe for it to happen once. But if you have infinite time and infinite quantum foam, then every possible fluctuation will eventually occur. This means somewhere in the quantum void, universes are constantly being born and dying. Most of them collapse back into nothingness within fractions of a second, but occasionally one survives and grows. We might be living inside one of these cosmic miracles right now. The most beautiful part of this theory is that it requires absolutely nothing to exist beforehand. No matter, no energy, no space, no time, just the quantum laws themselves, which might be the only thing that truly exists forever. But if quantum fluctuations can create entire universes, then our cosmos might not be alone in the void. Right now, as you read this sentence, infinite copies of you are reading infinite variations of these words in infinite parallel universes. This isn't science fiction. It's the logical conclusion of our best physics theories, and it completely changes how we think about what caused the Big Bang. If the multiverse theory is correct, then our universe wasn't a unique event. It was just one bubble in an endless cosmic foam where new universes are born every quantum moment. Imagine blowing soap bubbles in your backyard. Each bubble is a complete self-contained world with its own surface tension and interior space. Our universe might be exactly like one of those bubbles floating in a higher dimensional space filled with countless other universe bubbles. Some are bigger, some smaller, some pop almost immediately, and others last for trillions of years. The mechanism that creates these universe bubbles is mind-bending. In quantum mechanics, every possible outcome of every event actually happens, but in separate universes. When you flip a coin, one universe sees heads and another sees tails. Both universes are equally real, but they split apart and can never communicate with each other again. Now, scale this up to cosmic proportions. Every quantum fluctuation that could potentially become a Big Bang does become a Big Bang somewhere in the multiverse. The vast majority of these baby universes have physics laws that make them collapse instantly or expand so fast that matter can never form. But occasionally, the cosmic dice roll perfectly, and you get a universe like ours where stars, planets, and life can exist. This solves one of the biggest mysteries in cosmology: why our universe seems perfectly fine-tuned for life. The strength of gravity, the mass of electrons, the rate of cosmic expansion. If any of these constants were even slightly different, stars couldn't shine and life couldn't exist. Instead of requiring a cosmic designer, the multiverse gives us infinite cosmic lottery tickets. With infinite chances, every possible combination will eventually win. But here's where it gets truly strange. These parallel universes aren't just theoretical. They might be constantly bumping into each other. When universe bubbles collide, they create patterns in the cosmic microwave background radiation that we can actually detect with our telescopes. We might be seeing the scars from ancient cosmic crashes right now. The mathematics suggests that new universes are being born faster than we can count them. While you've been reading this chapter, trillions of Big Bangs have occurred in the multiverse. Each one creates an entire cosmos with its own galaxies, stars, and potentially its own civilizations wondering about their origins. This means the question, what caused our Big Bang, has a surprisingly simple answer. Absolutely nothing special. Our universe is just one of infinite cosmic accidents, no more significant than a single raindrop in an endless storm. But the mechanism that allows this infinite cosmic reproduction might have started with a single revolutionary moment in our own universe's first breath. In 1980, a young physicist named Alan Guth solved one of cosmology's biggest puzzles and accidentally discovered how to make universes. Guth was trying to understand why our universe looks so remarkably uniform. No matter which direction you point a telescope, the cosmic microwave background radiation, the afterglow of the Big Bang, has almost exactly the same temperature. This is like finding that every room in a massive hotel has precisely the same temperature, even though they've never been connected by heating systems. The problem was timing. Light from opposite edges of our observable universe has been traveling toward us for over 13 billion years. But these regions of space have never been close enough to exchange energy and reach the same temperature. It's as if two people on opposite sides of Earth somehow coordinated their watches without ever communicating. Guth realized that the early universe must have undergone a period of incredible expansion. So fast that regions that were once in contact got stretched to opposite sides of the cosmos. He called this cosmic inflation, and the mathematics were staggering. In less than a trillionth of a second, a region smaller than a proton expanded to the size of a softball. Think of it like a deflated balloon with two dots drawn next to each other. When you inflate the balloon, those dots end up on opposite sides, but they remember being neighbors because they still have the same temperature. That's exactly what happened to our universe. Regions that are now separated by billions of light years were once quantum neighbors sharing the same conditions. But Guth's discovery had an unexpected consequence that changed everything. The energy field that drove inflation, called the inflaton field, doesn't just turn on and off cleanly. Once inflation starts in one region, it tends to keep going in other regions, creating new inflating bubbles that become new universes. Picture a pot of boiling water where bubbles constantly form and rise to the surface. Each bubble represents a new universe being born through inflation. Our universe is just one bubble that stopped inflating and settled down to produce stars and galaxies. But the pot keeps boiling forever, creating infinite new cosmic bubbles. This process is called eternal inflation, and it means the multiverse is constantly growing. While our universe has been evolving for 13.88 billion years, the greater cosmic structure has been generating new universes non-stop. The rate of universe production is so fast that even though individual universes like ours are incredibly rare, infinite numbers of them exist. Guth's equations show that once inflation begins anywhere, it becomes mathematically impossible to stop completely. There will always be regions where the inflaton field is still expanding, birthing new cosmos, like cosmic factories that never shut down. The most incredible part, we might be able to detect signs of this process by looking for collision marks where other inflating bubbles bumped into our cosmic bubble before we fully separated. But the energy that powers this cosmic reproduction comes from one of the strangest states of matter ever discovered. Imagine you're sitting in a chair that you think is perfectly stable, only to discover it's balanced on the edge of a cliff and could tumble at any moment. That precarious situation might describe the entire quantum foundation of our universe. According to some of the most advanced physics theories, the Big Bang wasn't an explosion. It was the universe falling from one energy state to a lower one, like a ball rolling down a hill. But this wasn't just any hill. This was a quantum energy landscape where the fall created space, time, and matter itself. In quantum field theory, empty space can exist in different energy states called vacuum states. The lowest possible energy state is called the true vacuum. Think of it as the bottom of a valley where a ball naturally wants to roll. But there are also false vacuum states, like ledges on a mountainside where a ball could temporarily rest but isn't in the most stable position possible. Here's the mind-bending part. Our entire universe might exist in a false vacuum state right now. We think we're stable, but we could actually be sitting on that quantum ledge, waiting for the right quantum fluctuation to push us over the edge into a lower energy state. If that happened, the change would spread outward at the speed of light, erasing everything we know and replacing it with completely different physics. But here's how this connects to the Big Bang. 14 billion years ago, the universe might have been sitting in an even higher false vacuum state, an incredibly unstable quantum configuration with enormous amounts of stored energy. When this false vacuum finally decayed, it released so much energy that space itself began expanding exponentially. Picture a tightly compressed spring that suddenly releases all its stored energy at once. Except this wasn't a spring made of metal. It was the quantum fabric of reality itself. When the false vacuum collapsed, it didn't just release energy into existing space. It created new space with every quantum heartbeat. The mathematics show that false vacuum decay can happen spontaneously through quantum tunneling. Even if the energy barrier seems impossible to cross, quantum particles can tunnel through barriers that classical physics says should stop them.